Let's look at acid and base pairs, so conjugate acids and conjugate bases. This is something that should be fairly straightforward and we'll go through pretty quickly. I suspect you won't have too much trouble, and then it's just a matter of practice. Okay, so we've said when we talked about acids and bases that in order for an acid and base to react, an acid has to have a base present, a base has to have an acid present. So these reactions don't happen in isolation. An acid can't donate a proton unless there's somewhere for it to go. And you may remember a similar situation when you talked about redox reactions in the past, perhaps in year 10. So now essentially what that means is that everything's going to happen in pairs. So once a base has received its proton, it has the potential to act as an acid, because now if the base has accepted a proton, it has the ability to perhaps give it back. Okay, so when a base accepts a proton, the species that it forms, or the compound that it forms, we refer to as the conjugate acid. So the base plus a hydrogen ion forms the conjugate acid. And if you have a look, the H2O and the H3O plus over here, the difference between these two is H plus. If we look at the acid, what we have is HNO2, nitrous acid in this case. Okay, so HNO2. If it's acting as an acid, it will donate a proton. So the overall difference between the species on the left and the species on the right will be the loss of H+. So the charge will go down by 1 because it's lost a positive charge, and we'll lose 1 hydrogen. If we have a look here, HNO2 was neutral, we're now negative, and then we've got NO2, we've lost a hydrogen. And that is known as the conjugate base, because now we have a negative charge, we have a bonding position free. That species would be able to accept a proton, reforming the acid. So the acid donates a proton to form its conjugate base, and the base will receive a proton in order to become its conjugate acid. So if we look at, say, HCl when it reacts with water, acid in this case is going to be hydrochloric acid. The base is going to be water. When HCl reacts, it donates its proton, therefore leaving behind the Cl-, and then the water will accept that proton, forming H3O+. So the acid has reacted, losing the proton, forming the conjugate base, and the base has reacted, forming the conjugate acid. So the conjugate base is always 1 proton less than the acid, and the conjugate acid is always 1 proton more. When we do this, if we're asked to identify conjugate acid-base pairs, it's always the acid with the conjugate base and the base with the conjugate acid. Okay, in that way, what we do is we pair them up with the things that are differing by only 1 proton. So each member of a conjugate pair differs by only H+. And pretty much that's it. I'll have a worksheet for you to work on this to have a practice, but have a look at some of the reactions that we've already looked at and see if you can identify the conjugate pairs. Where is it that our acid has donated the proton, forming the conjugate base, and then can you identify the base and pair it up with its conjugate acid?